All right, welcome back everybody to another Open Game Data Open Office Hours. So just as a reminder, the Open Game Data community is an NSF-funded research incubator with the goal of bringing together a collective of researchers interested in understanding human thinking, learning, and decision-making with the use of data generated in and around games. We've got two primary objectives as a community. One is to compile a collection of resources and best practices on how people approach this kind of problem. And then number two is ultimately to build some concrete research infrastructure that encodes those best practices and makes it easier for all of us to share our work and do our work together. We have a number of resources that already exist. We've got the Open Game Data website, which is hosted by Field Day Labs. It's kind of the prototype of the thing we want to eventually build. We have a Slack channel where we all coordinate with each other. And we have these open office hour sessions that we do to sort of share out and have ideas. I probably need to update these links soon. These open office hour sessions, how these sessions work is they're inspired by a series of sessions that used to happen at the Statistical Education Research Group here at Carnegie Mellon, where somebody, usually a postdoc or a PhD student who had a problem with their research, would go and talk to a member of the statistics faculty and kind of say, here's my research question, here's what I'm trying to do, here's all my R code, here's all my data, what's going on. And often that faculty member would kind of come back with like, okay, well, what is your real question? And they'd kind of ask about their motivations, and then they kind of walk them through what they should be doing differently. But the twist on this is that they would do it publicly. Anybody else could just sit there and attend, figure out, and watch experts thinking and process. And so I like to joke that when I was at CMU, like everything I learned about statistics was from these sessions and not anything that I actually took in a class. And so the idea here is we're trying to replicate that kind of idea of how are experts thinking through this problem of working with game data to understand research questions. Some things to keep in mind: presenters are often showing stuff that's in progress, kind of intentionally. Those are the main things we like to show off here. And so often that can take some courage. It also takes some consideration. Not everything's final. Not everything is fully claimed yet. And that's kind of the point. Our goal is to help the presenter understand and achieve their own goals, but also anybody here, it's meant for learning for all people involved. So if somebody mentions a topic you don't understand or haven't heard of, feel free to raise a hand, ask a question. Or if you've got some input or some insight, either for the presenter or other people, feel free to contribute that as well. And with that, I'll hand off to our presenter, Jeremy.
Thank you. Hi, everybody. I'm Jeremy
away.
Roberts. I have a background in physics, but got into software architecture and engineering, and then eventually into data and data analysis, and landed at PBS Kids, where I saw a really interesting opportunity around gameplay for learning and data and learning engineering and learning analytics and so on. So I got pretty deep into that over about 10 years. And so now I still have that bug. I'm not working with PBS Kids any longer, but I still have that bug and I still tinker around in the space. And what I'm hoping to show today is just a little bit of work that I've been doing lately to help me answer almost a macro question. There's a couple ideas that have just been bouncing around and in my head and a couple other people's heads who I've worked with over the years. One I'll mention just by name. His name is Greg Chung. He's at UCLA Crest. And he used to ask me questions because he knew I could build things. He used to ask me questions all the time about whether we could do this or could we do that or could we try this, could we try that? And I think this idea may have originated with him. So I just wanted to get that out there. But I'm tinkering with it now. So I want to show it to you. I'm calling it PGT, which stands for PetriNet Game Telemetry. And I'm just going to start sharing my screen with everybody. And I hope that this works. There we go. Okay, can you all see this deck?
Yep.
Okay, great. Yeah, so PGT is PetriNet Game Telemetry. And I'm going to go through this in detail, but essentially I wanted to see if I could unify a model of the game with simulation of traces of like telemetry data from gameplay, but use an integrated and unified and internally coherent learner model all at the same time. And I'll sort of get into why I was going after some of that stuff. But at the top of this, we get a game eventually at some point in a learning game development process. And hopefully we're able to put it in front of real players and we get real data and we're able to learn a lot from that. But at PBS Kids, I watched the production process and all of the things that preceded that. And I thought there were probably a lot of opportunities in the earlier stages to get some of the harder questions answered, and to learn things earlier in the process and potentially to learn things that we were learning after building a learning object and launching it, distributing it to millions of kids, and spending a lot of money to get some of these answers. And maybe, just maybe, some of the answers could be obtained earlier and less expensively. So I don't think that this really represents new ideas so much as possibly combining some things in a new way. I would love any feedback or any questions about all of that. But if you simulate an agent, depending on how you approach it, there's some drawbacks. It might statistically look like the trace data you get from real learners. But every time we messed around with it where we didn't actually have the game structure somehow embedded within the simulation, we bumped into problems. Maybe it would look statistically valid, but it would show traces that weren't actually possible in the gameplay, or and so on. And so this is really about trying to make a more formal interaction space model that integrates with all the other pieces. So, and we did sort of a number of different approaches over the years, and eventually conclude, well, we got to patch the game structure on as a bolt on and monkey patch it later. And that what I'm trying to talk about today is not doing that. Let's see if we can't formalize the game model from the beginning. Yeah. Was there a comment or good stuff?
No, just that was the piece I was missing looking at your document.
Yes. Okay, good. Yeah. For everyone's benefit, I did before this talk send an overview to David. So, okay. So looking at some of the options that I had available to model game spaces, state spaces, transition spaces, all that kind of stuff, I ultimately arrived at colored PetriNets for some of the statistical properties that they have. I'll get into that. But I recognize that as a game designer or somebody who, with the people that I typically would work with on a game production effort, they don't know what colored PetriNets are. They don't understand the tokens or all of that statistical and mathematical jargon and terminology, and even visual representation wasn't going to be useful to them. So there was probably a different representation that I needed to contemplate as well. So ultimately, where PGT nets out is you can model the game space in concepts that are very familiar to a game designer, and it's capable of one-way compilation to full colored PetriNets. I'll show that in the live demo. So some of the ways that I was thinking about these flows, you can model your game and use that to simulate data. You wind up with some synthetic event logs, but you could also, I wanted to also have it run both ways. If you had some real event logs, you could parse them and maybe recover a game model from that. And then either type of event log, synthetic or real, really, this is real, but it's really either. You can do all sorts of conformance checking, finding deadlocks, finding end states, do all sorts of things with that formal model of the game interaction space become possible and checkable, even automatable. I looked at state machines for a little while, but eventually rejected it because of how things explode in terms of combinations. And the PetriNet approach really had that sort of massive concurrency that I thought might be needed baked in. It was much easier to represent a very large space with PetriNets than state machines. Okay, so I'm going to switch gears and just show you a couple things here. First up, I think, oh boy, it's tough. My Zoom is over where I need to manipulate my tabs. There we go. Okay, first up, I just want to set everyone's context with the game model that we're going to be looking at inside of PGT. This is based on a real game. It's a PBS Kids game. It's a Curious George game. It's targeted at 3 to 5s. It's part of a suite of games that were focused on counting and cardinality in terms of learning goals and domain expertise. It was produced by GBH Boston. So in this game, I don't think you're going to get my audio because of how Zoom is set up, but I'll just narrate. In this game, you've got a meatball launcher and a plate of spaghetti, and you're given a target number of meatballs, and you can launch as many meatballs as you like onto this plate. And when you're ready, you can go ahead and click the bell. Click the bell is sort of, it's ready, order up. This is my submit button, if you will. So I can put two, depending on my target, I can put too few meatballs, I can put too many meatballs, or I can put exactly the right number of meatballs. It's a very simple game, and it's what I chose early on with this PGT platform because I wanted to test it against something that was very contained. Okay, so you get the idea there, I think. Let me go ahead and show you what Meatball Launcher looks like. Now, I am in the game view right now, and what we are, actually, let me go over here so I can click this. Hopefully you can see the edit pane well enough here, but we've got screens, we've got variables, we've got choices that can be made, we can actions that are possible in the game, and my hope was that I could allow someone to create a game model, someone that had already been working in the game space, that understood games, and that all this would look familiar. I've got these states, and I've got these transitions between them, and so on. And I wanted to make it really easy to model, and then also I wanted to be able to put on knowledge and skills and abilities type metadata and set up my own archetypes, which we'll get into these in a little bit. But this essentially are player profiles. So this is Meatball Launcher represented in the game designer or game production lexicon. You got your title, you got a round, you add a meatball, you start the game, maybe you add a meatball, maybe you ring the bell, you had too many, maybe you rang the bell, you had too few, you can retry. Maybe you were correct and it transitions to the next round. And then there's a set of values. In this particular game, there's only a certain number of target numbers of meatballs that it will ask you for. And then eventually you got a terminal state. Like you keep playing until you're ready to stop and you stop playing the game. So very simple game, but relatively easy to represent in this system and relatively easy, I think, to sort of visually grok. And now, does that scale to large real games? I don't know. And that's one of the main questions I have, which we'll also get more into a little bit later. But here is Meatball Launcher in the game designer vocabulary, if you will. What PGT will allow you to do is also to look, is to look at both the game designer view and also the colored PetriNet that it compiles down to. So this is the actual PetriNet setup, the actual underlying statistical machinery. But if you're a game person, you don't need to worry about it. Or you can look at them side by side and see the correspondence. I just highlighted title here. And so over on the PetriNet side, title's highlighted. I could highlight any transition and you can see, so you can get a sense for the correspondence between these things. Or you can focus entirely on the PetriNet side if that's what's important to you. I wanted this model to be able to simulate data. So I've got a set of archetypes. So let's actually go back and look at that briefly. So you can see how that's set up. In this case, all I have, the only learner model, the only cognitive model that I've tinkered around with yet is the simplest one I could think of that met my needs, which is a Bayesian knowledge tracing approach. And you can see that I've got a number of archetypes set up here. And essentially, all of the things that maybe you'd recognize if you've ever done any BKT work, you can configure. The idea, I think, would be you could configure this manually if you wanted. to get a starting place and see what that looks like. But you could also, if you had the game and had real data and could compute some of these calibrations from actual data, then you could fill that out as well. And that's going to be a theme here. I'm also kind of hoping that a system like this might allow profiles to get created, but also refined over time so that we could assess whether they really do generalize across games and across interaction spaces and so forth. But for now, only one exists in the system. It's BKT, and these are not based on actual training data or anything like that. This is just manually configured to help me prove out the platform functionality. So, but I do have novice, and as you would probably expect, the factors for novice are different from, say, maybe advanced in a way that would allow the advanced profile to drive the model with more, higher levels of correctness, possibly speedier guesses, and so on. And you could tune all that if you wanted by tweaking these parameters. So when I get to something like simulate, I can say, oh, well, I would love for you to think about all of these archetypes, and let's do 10 sessions in archetype. And seed here, everything that gets simulated by PGT is reproducible. It's deterministic. So if you set a seed, I could set a seed. And if I gave someone else that seed, they could actually reproduce my simulated data set exactly. And I can say, how many steps do I want each session to potentially hold? And I'm supporting a number of interchange formats, XAPI, XES, CSV. And because we do have that learner model, because we have that cognitive model integrated into this, and I'll talk about that a little bit more, how it's integrated and how all the things affect each other. But because that is integrated, I can have the BKT estimates for example, like a latent mastery value. I can have that annotated onto the trace that it generates. So just simulating some things that got a number of sessions, how many got to the end, how many events were taken, and so forth. And this is so I can generate like log data, simulated log data with these profile characteristics in the format of my need. I also can verify the model that we're looking at because it has those PetriNet properties. I could, for example, add a check where I was like looking for, deadlock. Are there any places where people are going to get stuck? And I could run a verification, and it found a deadlock on the model that I just showed you. Now, in this case, it's trivial. It's saying that the game complete state, which is as expected. Okay, but this is the idea, is that this trace got to the final game complete state and correctly found that as a deadlock. And if I was someone trying to design the interaction space, I would now know there's only one in that graph, and that traversal will only ever deadlock at the game complete, which is good. That's what I would want.
Mhm.
Conformance, this is the place where you could, if you had exported some simulated data, or if you had real data that was model compatible or PGT compatible, you could bring it here and put it in, and it would be able to help conformance check your trace or any trace. So multiple people using PGT could be trading traces, real, simulated, doesn't matter, and be discussing. And I have a small number of checks built into the system right now, but I think it's ripe for extending. And then analysis, I could, for example, here just want to look at novice and advanced and do 10 sessions per each, and maybe just look at a little, look at a little A/B comparison between these. 10 sessions, sure, why not? And now I can see that my current configuration of the novice archetype versus the current configuration of the advanced archetype, both complete, but take wildly different durations and different number of steps, and the error rate is very different. And so this might give me, especially if I know the game well or my audience well, this might give me some counter pressure back onto my archetype configuration values and so forth, if I haven't yet got real data to tune those with. And then, I don't take this very seriously, but I am computing p-values here, and just a quick 0.05 significance check. So that's the overview of what I have with PGT, but I do want to switch back to my deck and get into a couple things here. I included the screenshots and the general purpose of each view that we looked at, so that if this deck gets distributed, you have all what we looked at: the game view, the both view, the colored PetriNet view, simulation, verification, conformance checking, and analysis. So that model allowed us to look at the data, or generate data, or interact with the model and the game and the design 7 different ways. I promised that I would eventually get to the point where I wanted to share about how BKT is in the loop. So that the game model, the colored PetriNet, determines what's valid, like what only structurally valid things are even on the table to be selected from. So that provides the structure. The profile is what sets those knobs, those cognitive model knobs. The current, for example, for the BKT, helps drive the behavior of the synthetic learner. And given the structure, it can only choose from structurally valid options. And then the behavior and correctness and so on and so forth then feeds back into whatever the mastery estimates are, and so on. So that's the loop we've got going on here. I don't think BKT is where this should stop. I've got a couple other ideas for things that, frankly, that I know a lot less about, but that I kind of want to get into. Performance factor analysis, deep knowledge tracing. I'm guessing that the group of folks here will probably have other approaches, maybe even approaches that you've developed yourself, that might be interesting to put into a system like this. But the point that I wanted to make is I made it pluggable. So yeah, BKT's in there now, but it's not hardwired in there at all. There's no deep, there's nothing's coupled. And I did my best at guessing what the larger space of models would look like from an interface perspective, so that we'd be able to drop things in. I don't think it'll be too much work. It'll be some work, but I don't think it would be too much work, especially if people have reference implementations. So totally on the table, like exploring things you've made or other things that we think that are out in the field that would be interesting to look at. Quick note on validity, the profile parameters, like I mentioned, they're authored right now, not fitted, but I really would be interested in calibrating some of those to real player data, especially from groups that have their own models and have been refining their own models for a while, and have they were doing that with their real data. I would love to get into that kind of thing. It's something I would have absolutely done if I still had access to the PBS Kids data. Did someone say something?
Oh, I was just saying, yeah. I mean, we could go into, if you got more you can talk about, that's cool. Or I have various questions about the BKT bit, but if you got more you want to cover first, we can do that.
I'm happy to dive in now, or I'm happy to finish up. I've got a couple more thoughts, and then maybe we'll move to discussions. Does that seem all right?
Sounds good.
Yeah. So yeah, one of the thoughts that keeps coming back up for me is whether there are there profiles that can be really generalize across game graphs. But let me put that a completely different way. I've shown you a game space model, but what's not in there is the difference that an animation that draws your attention at the right time to the right thing. That's not modeled. The choice of the transcript, the script, the voiceover for a piece of instruction uses, that's not modeled. Some of those are going to be good, some are bad, and there's just going to be a range in between. And so I'm pointing at that there are a number of factors in actual game and game design that have a material impact on outcomes that aren't modeled in PGT yet. So I think that's another big space, and that will play a big role in sort of helping answer that question, whether that, like, what does it take for profiles like these to actually be valuable and to actually generalize, and how much of it is game specific and how much of it generalizes, and so on. Yep, I think we covered this. Cheap test rig earlier. No PII concerns with any of the simulated data. If you get to the point where it's valuable and it's helping, it becomes a lot easier to make it, a lot easier to share it, and so on. And, depending on how many people you have in your audience, there may actually be intended pathways that only get exercised a relatively small number of times. And the synthetic aspect of this, I think, might help with N. Yep, I think we covered that. Input, output. And then finally, this is an aside, but there's a UAT suite where every bit of the user interface is spec'd out step by step, exercisable, and a human can go through the test suite and conduct these steps. And if it looks good, they can certify it as, yes, this test passes. And then once a test passes, it gets added to an automated test suite that can run headless against the actual application using automations. So I'm very sensitive to the range of output quality that some of the modern LLMs and AI generated code can result in. And so I think very deeply about making sure that the layer that gets interacted with, or the math aspects of things, are all unit tested and user acceptance tested, and have the human very, very much in the loop of saying, yeah, actually, this looks like I think it should look, and so on and so forth. Yeah, one small game, one learner model, validity and calibration. Yeah, and I think I mentioned this, but I have only looked at one tiny game. I have no idea whether this kind of approach is going to hold up on a big, complicated one. I don't know. So, okay, that's my spiel. Thank you for listening. My hope is that I could help myself really learn what you all think, what questions you have, and where something like this should go, if anywhere. Thank you.
Wow, super cool. I have a bunch of questions about the VKT bit.
Okay.
So I did a lot of learner simulation stuff in my past, so we can also maybe talk more about this in the future. But so you said so you just ended doing the standard VKT forward simulation math Bayesian update rule based on feedback and stuff. But you said here that based on the current P known decides which legal move. How do you choose among the misconceptions? So like in your current one, there's one correct move and two incorrect ones that potentially imply different forms of misconception. Um, and do you just kind of shuffle, or like what's this?
Yeah, it's simplistic. There's no concept
Sure.
of misconception
Okay.
here, yeah, at all. It's in fact, I would point at the learner model, the cognitive model, as almost being a piece, a placeholder that I knew needed to be there to hold up
Sure.
the wider platform. But I would say it has not
Something that
gotten
has to make decisions among options, and right now it
right.
just flips a coin. Yeah.
Yeah, it's not doing anything special or interesting.
And
Yeah.
then
Oh,
another
I
thing
was
I'd
going to
be,
say,
yeah, go
I
ahead.
have some of the next few things that I have on my list to look at when I get some time. There was an interesting paper, I think is 1992, Karen Metz. She got a whole bunch of real preschoolers in the lab and started asking them to interact with pan balances. And she mapped out all of their actual approaches in excruciating detail. And that illuminated a number of misconceptions that they started to see the kids have. Like one example, just to make this concrete, was the higher is heavier misconception, I think it was. And the idea
Mm-hmm.
there is that if one side of the pan bounce goes higher, then a lot of the kids have been conditioned to believe that anything that was higher or more or whatever was better or bigger. So their idea was that that must be the heavier thing. And they actually saw this bear out in the kids interacting with real pan bounces in the real world. I think that's a much more rich space of choices that the learner model would have to make, misconceptions that have already been detailed by the qualitative research. So I would hope that maybe a next step for this would be to move into a real space that had a lot more of that stuff defined.
Well, if you're interested in that, I have a game that is a balance beam positioning weights
Yes,
on
gonna say,
pegs.
I've seen one of those.
Hey.
And I have log trace and even KC models.
I am interested. I am interested. Yeah. Let's talk.
Because my other question was going to be, I think another thing that would be a really useful early next step on this would be exploring a multi-KC model.
Okay.
And how does the Q matrix map to the PetriNet? Like, how do you map the KC? Because like the same KCs are not going to always be implicated at every transition. You're going to want to be able to map them to transitions.
Yes.
And I'm curious how that works on the designer interface, how that works for the PetriNet. I know how the math works in the BKT, but
right.
But how do I assign it? And then also, how do I audit if I'm wrong? Because that's a lot of what we do with like AFM and PFA and stuff is checking, is our mapping of KCs actually bearing out in what we see in human players? And that flow would be really interesting to explore with something like this. It's also, I think, a really challenging thing to do in games currently. Paul and I put in a proposal about that.
Which part is most challenging, would you say? Because I consider myself relatively naive on this question, but my take on what you were saying is that maybe you get a little bit of a little bit of help by the fact that the interaction space is formally modeled, and you could actually map KCs to individual transitions, or say, oh yeah, so you would have the space that had all the locations, and you could be declarative about it. And you could facilitate it through a web interface and so forth.
Being able to map it out helps a lot. Though I'm also wondering, like my classic example of thinking about Q matrix identification and the challenge of it is actually thinking about the Wake game from Field Day, where there are lots of ways in which you might transition through the space of that game, but you're doing different things when you return to different scenes, and it's like, how do those get treated in this state transit? Because like, how do you account for that kind of state when it's not necessarily state transition through game world, but state transition through sort of like game progression?
Yes, it's almost like a hybrid learner game state machine on top of the interaction space graph. Yep, I see it. I can see the architecture. We would need to do something like that. Not in here, but I can kind of see the shape of that. Yeah.
Any open world game would have that kind of structure.
Yep.
Where you're pathing through regions or levels aren't the thing. It's challenges that could be enacted in many times that are.
But if you could like segment the game into like some of the stuff we've been talking about around our logging schema would define segmentable moments or segmentable pieces. And within a segmentable piece, you could easily do this across a bunch of them where they might overlap and show up in different orders and be fundamentally unordered. That would get a lot more gnarly. But
when you said a little bit earlier, you made a comment about potentially or having a challenge around figuring out where you messed up the KC mapping. Could you say a little more about that? Like, or checking your own work, I think you mentioned.
Yeah. So my paper from Kaiplay, literally on this balance beam game, several recorded open office hours ago, you can also check out. But essentially the idea is a thing that we do with around our use of KC models, and particularly around data shop and stuff we do at CMU. But essentially the tool is you use the additive factors model, which is sort of the precursor to PFA. And you take a Q matrix, which maps KCs to steps in a problem, or in this case, it would be challenges, transitions, pieces in that PetriNet, whatever.
Yeah. Yep.
And you fit AFM. And one of the original formulations of AFM hasn't made it through to some of the more modern rewritings of the software, had a constraint in it where learning rate couldn't be negative. And so cases where learning rate would be negative would be turned to 0, which would produce a bad fitting model. And when you plot the fit curve against actual human data, you would see these spikes up. And so the statistical model assumes unlearning is impossible, but then you see unlearning in real data. Usually that means your mapping of KCs to steps is wrong, and that you have to go and update your mapping of your KC model to steps.
Yeah.
And then when you do that, usually you get a better model.
Oh yeah, unlearning is real. I found out the hard way. At least so I have an anecdote. We made some learning objects. We packaged them together into a collection. We were doing a large scale, very expensive RCT to see what the effects were. And everybody was really super happy about it, but we needed to find a control. And so we grabbed some other PBS Kids games that had to do with completely separate topics. But the learning goal was around forces in motion. And one of the games that made it into the control, I think it was called Pinado or something like that. And it had totally fantastical physics going on in that, with tornadoes and things swirling around and like magical behavior. We just picked it because it wasn't related to forces in motion. But it turns out actually, and we did see some effects when the groups were compared against each other. But the truth is, the intervention group did not get better. They stayed the same. So really the intervention that was supposed to help them did not really help them. So how did we see effects? It's because the control group got worse over time on their understanding of the assessed, the pre and post. So fantastical representations of things adjacent to what the learning goals were over in the intervention group actually produced a backslide. Yeah.
But the actual interpretation from AFM and the way that we think about it at KCs, it's not unlearning doesn't happen.
Okay.
It's that they're learning something other than you thought they were, which is what's happening in that case. So they're learning a confounding, and then they're confusing their ability to distinguish between the two. And so that's why it's unlearning doesn't happen. If you see unlearning, that means your conception of the skills going on the steps is wrong, and they have to be reassigned. And so that would be really cool to explore in something like this, is a misconfigured mapping of skills. And being able to see it, and then being able to see it in real data, being able to see it in simulated data.
Cool.
One of the just packages of questions I've got is, I mean, we're circling around a little bit, but it really trying to understand how well this kind of modeling scales up from simple designs to complex designs. And I can't quite get my head around that yet. Like, it might be that the only way to do it or to learn it is to try modeling more sophisticated games. But I just am curious if you've got some thoughts on that. And broadly speaking, I think it has to do with the act of modeling games formally in a general way, right? Like, are there theories around that you're aware of? Because I've never really considered it, to be honest.
Yeah. So first, a disclaimer: I've thought very deeply about a lot of very simple games at PBS Kids. So like my bias is overwhelmingly towards 2 to 8, and not even really a lot of 7 and 8. Like I'm talking 3 to 5, 3 to 6. That's
pre-reading is that sweet spot, right?
Yeah, that's what I have the most experience with. So when I crafted PGT, it seemed natural to me to create a vocabulary around places, like locations in the game and transitions between locations in the game. It strikes me though that if you're going to expand your cognitive capabilities and your age range as a proxy or whatever, like let's just go all the way to Elden Ring for a second. I don't know if anybody here plays games.
If you can nail that, you can do games.
Yeah, I'll guarantee you the vocabulary that PGT has won't even cover 1/100th of what would be required to map something like Elden Ring. there's just so many sophisticated systems. I don't know if Elden Ring is the best example because I don't know who's familiar with it, but I'll try to be descriptive here. You've got the world and various enemy types that are in and of themselves their own individual challenges and or but there's also hundreds and hundreds of weapons and tools that you can wield. But there's also flavors of each weapon or tool. You could make them flame, you could make them sleep, you could make them poison, you could make them ice, and then on top of that, there are modifiers and multipliers and muters that which the game calls talismans and other things that you can equip on your character that really either superpower certain aspects of a thing or tamp it down, and then there's the player character and all of their statistics. That's a very high dimensional vector. There's a large number of stats, both visible and hidden, that are upgradable and manipulatable and sometimes conferred just because you have a shield that you're wearing on your back or what. So yeah, like that, I will give that more thought. PGT is not built for that now. The question that I heard was, what would it take to have a vocabulary?
Is it possible even?
Is it, or are there multiple like realms? Like this would be good for the younger kids, but then we might need another vocabulary for K-12, and then we might need another vocabulary for secondary or entertainment. I don't know. I'm not sure. I'll think about it though. Great question. Thank you.
Paul, did you want to jump in?
Yeah, I think one of the interesting things about complex games also is and I'd be curious to see the data from these simple games to see how much this happens there too, but that you end up with these outrageously large state spaces, but that are explored very sparsely.
Yes.
And individual player trajectories within that space might be very different. But it's even just kind of statistically speaking, like most of that state space will never be explored. If everybody played it for their entire lives, most of the state space would never be explored because it's just so big. And I feel like there's something about that you could maybe work with to figure out what does it mean to describe these things. But yeah, Jeremy, thank you for sharing this model. So I'm actually also, my background is also in physics. And I've also thought quite a bit about formalizing game models for predicting before playing and things. So I'd love to chat more offline sometime.
That'd be great. I would love it.
I think a lot of my focus was on thinking in terms of grammars and state machines and board games, rather than these kind of UX graphs and PetriNets and learning games. So it's really cool to see kind of how you approach things here. I need to go read up on PetriNets. One thing that I came to in trying to think about how to write down a board game formally, to start studying it, comparing it with others, whatever, is kind of different layers of description. When you commented on these sorts of like the audio cues or the visual attention pointers or things that don't get captured in the model but are relevant, it reminded me of this. The layers of description that I eventually came to were, you can describe the rules in one sense as this is what an omniscient judge would see. They know everything about how everything works. But from a completely abstract level, like they just see the PetriNet or the state machine, as it were. Another level is add on the hidden information. What are the bits of like the hidden cards or even the hidden rules? Like the players don't know what level is coming next, so they can't necessarily plan for it. So what are those like gaps in knowledge? And then the third level is where like the actual user interface comes in, of like how the players are actually interacting with this system that has some hidden information or rules. And that each of these introduces new dynamics on how decisions are made and how players interact. Designers don't typically think about separating these things when actually putting together a game, because you just build it like kind of with the information and the interface and everything packaged together with the rules. But
all integrated.
I wonder if there's a fruitful way to think about that separation in terms of modeling and learning, to see like, if players could see everything on an abstract system, they would behave in this way. But now once they have to remember some things because there's hidden information, the learning declines. Or now once
Right.
there's this interface in this shape, now it changes in this way. I wonder.
Mhm.
And,
I'll respond to that one actually, is that's always how I've, at the highest level, defined in my own mind how learning happens in games, is that the player is building an internal representation through probing a hidden system using the mechanics and feedback systems of the game. And there's always a mediation of the interface to the simulation behind it. And the goal of a learning game is to have the student internalize the simulation. And the design of the game is the scaffolding of the interface in order to reveal that in a useful way.
Let them probe it, yeah.
Yeah, so I've always thought of that as like, that is the work of an educational game designer, is to figure out exactly how that system reveals itself and when it abstracts and when it hides and when it reveals and in what ways, because any complex game, the simulation is more things that a learner could ever handle if you just gave it to them all at once. You've got to lure them in through smaller mechanics and smaller feedback and then slowly unpack it.
And it's that probing aspect that's what makes the blame assignment problem of an action to a KC gets hard to do, because it's like, which one were they trying to use? That's the one that should get updated.
That's right.
Right.
Not which one is the correct answer to this problem.
Right.
That's right.
Per se.
Right.
Yeah.
Right. Productive struggle, right? Because often the wrong answer is part of a sane and effective and efficient probing strategy.
That's right.
Tells
It's part of the exploration of the system.
Yeah.
Because, yeah, negative consequences are consequences, and they are just as useful as positive consequences.
Right. Yeah.
You know,
sometimes we win, sometimes we learn.
Yeah, exactly. Gosh, I've got so many questions about this too. Okay, so one of the other just anecdotes was when we made Wake, we had this problem that it's open world-ish mostly, but it's got jobs, and these jobs are like their own internal narrative, packages with goals and subtasks and stuff. And we ended up with something like 53 of them. And there were some natural storylines that required some of them to be sequenced. Just logically, they just needed to be sequenced in little packages of 2 or 3. But then there was a lot of it that really didn't have to be sequenced. But as a designer, we realized that they needed new tools or they needed new skills. So we had to put in a way to sequence it. So the main way we put in place was we gave you a store where you bought the different tools that you would need that would increase in complexity for these scientific practices. And the store would create a natural sequence because you couldn't just buy everything at once. Okay, so we had a balance across the requirements of a job, and they could have prerequisites of each other, which we didn't use very often, and then the requirements of the job to the store to then money and experience points, 2 different whole metrics, right? So when we were designing that, it was like, how can we know if people are going to get stuck or not, like soft locks? And the way that we solved that, after hearing about horrible things that were happening during our playtests, was we just wrote a brute force checker. And whenever you update any part of that prerequisite graph, we run the script. It'll tell you what conditions led to a soft lock, and then you can tweak how much money or experience things require so that you could find a balanced system. And we just use it as a QA test. I say all of that in that this seems like one of the things it would provide would be a generalizable QA system for not only that problem, which comes up pretty commonly in our games, but also a QA system for the kind of analysis that Luke and team have been running recently, which is people are winning the game. Are they winning it the way we want them to win it? So statistically, a dumb agent, just noise going at the system, can it win in ways that we don't want it to win? Because again, in learning games, the dominant strategy is the lesson, right? It is the learning objective. So it's like, does the system produce emergent ways that the designers weren't thinking of that are actually unlearning or having the same or opposite message that we want? So I'm just curious kind of throwing that whole thing out, if you've got thoughts that while you were making this around that, like the QA and analysis part of things.
Yeah, I think graph checks like deadlock, reachability, liveness, boundedness, and so on. That's some of the stuff that I think PetriNets have locked up, right? That's they have features where you can just do that, and the machinery will allow you to check it. Where I start to get super fuzzy is the previous conversation we had about a much more robust game with a much larger vocabulary and a much richer set of interactions between the concepts in the expression vocabulary. Whatever it is you're using to model that graph, if it gets much more complex, I honestly don't have any experience that sort of leads me one way or the other than to say PetriNets themselves, if that winds up remaining a suitable technology to serve as the foundational layer, and we could figure out a way to build all that richness on top of it, in theory, should be able to maintain those properties. Yeah.
I wonder if chess would be a nice use case. Something that's got 64 squares and 6 pieces, different moves. Like not hard to model, but 10 to the 1/20th possible
right, much larger.
outcome states.
Yeah.
I wonder if that would be like a nice next step for modeling.
Might be better to do something like Minesweeper. The yummy mitigated decision process of chess in competition is going to throw you for a loop, but having to model the opponent to model your next move.
Right.
Whereas
many moves in advance. Yeah.
Whereas something like Minesweeper is still grid based and still combinatoric, but it's one player.
Fair enough. Yeah. This thing is something with a huge amount of possibility spaces, but a small amount of rules. And it seems like that would be one kind of experiment here.
You alluded earlier to using the game logs to back out the rule systems.
Yeah.
I wondered if you could say more about that.
Yeah. Well, that's the dream, or part of the dream, is that if you can maintain parity between the game model graph and the machinery that you use to create synthetic traces, does that operate in both ways? And at this simplistic level, at the level of Meatball Launcher, it can. You can take a trace for Meatball Launcher and you can come into a PGT instance that has no game models, and you can import the log and it will start to flesh out the model for you. Now, the completeness of the game model is limited by the completeness of the logs. Like what level of exercise of the full graph does the log represent? Right? It's always just a sample, but yeah, it is right now at a very limited Meatball Launcher level. I have had some two-way success. Yeah, I have no idea. I wouldn't even know how to start even a mathematical proof to inquire whether you could maintain that into larger space. I don't even know. That's out of my wheelhouse.
Yeah.
But oh, go ahead.
It has to be just fundamentally discrete, correct? Like continuous game spaces or
I think so. Yeah.
Or time-based challenges might be difficult. Yeah.
I think in both cases, to get somewhere, you have to make some assumptions on kind of what, on the sorts of structures that might appear. Because even in a discrete thing, given any finite log set, you'd never know if the things that are missing are because they're illegal or because nobody just never does them.
Yeah.
And continuous would be analogous.
You'd have no way to assess completeness, as far as I can tell.
But you'd have completeness over logs you have thus far observed, right?
Yeah,
right.
At least. So
that's a nice start, right? If you all of a sudden you have 70, 80, 90% of the states and 90% of the transitions and the connections, the arcs, the edges, you could you would know what was permissible, or at least a subset of what was permissible.
Because that could be an interesting way to get around the like the combinatoric explosion of a really big state space rather than map it all out,
Yeah.
just empirically do it.
Yep.
Because
Right.
that's the part you're going to care about anyway.
Brute force it. Yeah.
And then you lose some of the capacity for things like reachability detection and stuff, or at least you couldn't say it definitively,
Right.
but you could do it among things you have seen so
Among
far.
what you had. Yeah.
Yeah.
I
Um,
can
I
say
actually,
this. Oh, go
sorry,
ahead.
no, please.
Oh, I was going to say, I can say, sort of related to this, the game designer view in PGT compiles down to the colored PetriNet under the hood. But if I were to have authored a colored PetriNet in the first place, I cannot, it is not deterministic. I
you
cannot
can't go back.
go back with 100% certainty to the game
Right.
design. So even what I have now has some aspects of it that are already one way only. Yeah.
That led me to another question, which is that I wonder if this could act as a tool for, like in our games, we're trying to come up with JSON structures that formally document the game design. And I wonder if we could generate one of these from that and then use it as a QA tool for knowing if our logging is correct. Meaning it would be able to identify what potential errors exist by looking at telemetry to say, well, that was actually a software error, that this event existed at this moment.
Can you say a little more when you say looking at JSON structures that capture how the game was designed? Can you give me a little bit more information on that? I want to make sure I understand what you're saying.
Yeah,
What kind
like
of
things like,
design? Yeah.
to use the Wake example, it's things like those graphs of requirements. We formalize those and export them in JSON so they can be used by data analysis down the road.
Ah, okay.
So whenever we've got data structures like that exist in the game,
Yes.
things like level progression structures that have, let's say you're playing Mario and you have to do it within 5 minutes for level 1 and 3 minutes for level 2. It's ways of documenting that so that they're with the build of the game and then can be used in later analysis.
Yep.
Because we just need them, otherwise you just have 1,000 questions between the analyst and the designer.
Yeah. So what I'm hearing, and tell me if I'm going off the rails. What I'm hearing is that you found it to be useful to decouple some of the configuration from the actual software. So you're not doing the meaningful configuration work inside of code. You're decoupling those, but the configuration is still machine readable and so forth. Where my observation here, or my intuition here, is that we're actually talking about PGT sits almost at a third part of that triangle because it would need the same software that read that configuration and implemented it in order to reason about the JSON properly. So now you're talking about an additional, you factored out the configuration to be a reusable and portable component, but now you're also talking about the code that works with that configuration needing to be factored out and decoupled from the game to be a portable and reusable component so that something like PGT could wield that as well. And then I think you could get all of those things relating to one another.
Yeah, I wonder if you could document that kind of description so that it would at least jumpstart the creation of one of the models in that software.
I think just to clarify just a little bit, like if I'm thinking about the right things that Dave's talking about, it wasn't necessarily that we separated configuration from the game in a way that was like loaded into the game or anything like that, and more that the structure in the game could be exported in a way that someone else could pick it up and understand something about the structure of the game without having to look at the game itself. And I think
the actual games. Okay.
And it's not like these were comprehensive, but they were, an external description of some of those in-game constraints and which things unlock each other, what some of the valid, moves are at certain points, or what some of the requirements are for different quests and things like that. And
so not just config. Yeah, go ahead.
Oh, yeah. So I was just going to say, I think that maybe the original question was more around, it'd be interesting if there's a way to think about a link from game to description of the game to a tool like this that that could like ease that transition and that modeling stuff.
Mm-hmm. What I'm hearing is that it wasn't just simple configuration, it was also topology. And even more than that, it was almost like a state space, kind of like what PGT is modeling itself. You had a serialization format that could represent that whole space on some limited. Okay,
Yeah.
makes sense. Yeah. Yeah. So right now the model in PGT is all database based, but I think it would be yeah, I think it would be possible to look at other representations that allowed for portability or exchange or whatever we might be interested in solving with that. Like you mentioned, like being able to take that topological description of some of your game systems and having this document you just read and get a sense for what it is. Like there might be visual representations we could make, like the ones that are already in PGT. There could be other file formats. There could be other things. Yeah, that would be interesting. What I would do, I would want to understand what specifically we're trying to do with that, and then I think there could be some interesting work there for sure. Yeah.
It's a question that just keeps coming up with us is like, are there ways to automate parts of the documentation for our games, like deep documentation, as well as ways to automate the creation of telemetry logging events?
Mm-hmm.
So, because right now it's just so human centric. We like sit down, we look at it, and then if we can automate it, can we automate the testing of it too? And obviously, this is holy grail for us. If we could hit a button on a game and it could, if as long as you documented it in certain ways, it would.
Yeah, and so David knows about a suite of open source software tools called Springroll that we helped develop at PBS Kids that contemplates the development of the game internals and the entire distribution ecosystem into which that game can fit, whether it's mobile or web or TV and so on, and all of the services related to that as well, all the cloud services. So the developer toolkit and the open source libraries, but also the cloud services that serve it all up and manage all the metadata, control the publishing, and then also the portable, accessible pieces of it. But that was something that I was actually working towards while I was there, because I had control over the Legos, the internals that our game developers were permitted to use to develop a new game. I thought if I could structure that properly, I might be able to get it to self-log, like all of the components that had passed our QA and were served up to all of our producers and game developers and that they were using to make their games. What if they all already included their own telemetry logging? And so I think so you mentioned that for sure, Dave, but this might be another interesting and useful extension of that, is how could a game show us an alternative representation of itself separate from the interactive version of it that helps us understand things or work with things or talk about things or communicate in useful ways. Yeah. Interesting ideas for sure.
Cool. So I want to be mindful we are at time-ish.
Thanks.
And we don't currently have anything on the schedule for the next session in 2 weeks. So if anybody has something they want to talk about, or if there's any updates on this we want to talk about, I don't know. But let me know. We can get people on the schedule. And otherwise, we'll make sure this recording gets put up promptly. And
yeah, I had a couple of people ask.
Cool to see where this goes.
Thank you, everybody.
Awesome. Yeah, awesome. Thank you for sharing.
Appreciate it. Don't hesitate to reach out. If anybody has any ideas or just wants to tell me how much they hate this, or if you love it, or whatever.
I just couldn't sleep at night. I was just thinking about how much I just hated that idea.
Yeah. It was so close, Jerry. You were so close.
I know,
to
and then
doing
you just
something
blew it.
good. Yeah. Thank you, everybody. Really appreciate your time.
See you.
Bye.
Thank you.
Bye.